Okay, so we are talking about unit rates. So first of all, this should be a little bit of a review from last year, I hope. Okay, so let's first talk about what a rate is. Okay, a rate is a ratio that compares two quantities of different units. Okay, some examples of rates would be like 78 students in 3 classes. What are the 2 units in that problem? Students and classes, right? Or I could say like $150 for 6 tickets. What are my units there?
Tickets and dollars.
Tickets and dollars. Okay, very good. All right. A unit rate compares the quantity to 1. We always want to know how much 1 is. Okay. Unit rates always have a denominator of 1. Some examples of unit rates would be 26 students per class, or $25 per ticket. Okay? You'll hear things like or maybe even for each ticket, per ticket, something like that. Okay? Those are unit rates, all right? So these actually are the unit rates for these examples up here. How did we get that? Well, first, to find a unit rate, we're going to write it as a fraction. And then, using division, we're going to write an equivalent fraction with a denominator of 1. Okay? So does everybody see how I would have gotten that one, kind of showing you the work? That one would have been 78 students in 3 classes, and I wanted to go to 1 class. So how did I get from 3 to 1? Divide by 3, and then the rule is what you do to the bottom, you do to the top. And so then 78 divided by 3 is where I got 26, right? The question might be, well, how do you know which thing to take down to the 1? What are you going to think? Like, how do you, like, why didn't I say 1 or however many classes for 1 student? How do you know which one goes to 1? Huh?
I think you should just use like some common sense.
It really kind of is. In this case specifically, you have to stop and think, are we going to do students per class or classes per student? You see what I'm saying?
Because there's normally less than 1.
Exactly.
1 student doesn't get a whole class to themselves.
And that makes perfectly good sense, I hope. The times when it gets a little bit confusing is when we start talking about money, okay? Because we did cost per ticket, which does make sense, right? But could you also see a time when you might want to do tickets per dollar? Maybe. If you were trying to see, like if you only had $1 and you want to know how many tickets you could buy with that $1, you see what I mean? But more than likely, it's usually the cost per ticket or per
Or
ride.
like, I feel like you also want to take into consideration, like if it's $25 per ticket, you can't really do anything per dollar. But if it's like 1 cent per ticket, then you might want to say tickets per dollar because that's like a lot of tickets in
True.
Or like more than that, but like that's easy.
Okay, so here's an example. They've given us 90 miles in 2 hours. They want to know how many in 1 hour. I'm hoping everybody sees this quickly. You would do what? Divide by 2, and 90 divided by 2 would be 45 miles in an hour. Notice that the answer to this question is 45 miles per hour, or written out. The answer is not just 45, because if it's a unit rate, the answer must include units. That's right, because it's a unit rate. If you just put 45, you guys are going to lose some points, okay, on your quiz next week. Okay, so there's 2 for you to go ahead and do on your own. Take about 10 seconds to do those. Okay, on the first one, We're going to 1 hour, so you should have divided by 3, which would have given you 40 miles per hour. And again, we're going to 1 hour here. We should have divided by 4, which would have given us 25 pages per hour. Does anybody have any questions on unit rate? Like I said, that was all should have been a review from last year's 6th grade. All right, we are going to move on. On the next page, concept of proportionality. Okay, if you were to look on the 7th grade star chart, okay, which you guys don't pick up, I see some of you picked up the 8th grade, that's fine. On the 7th grade star chart, it says constant proportionality, so you might want to write this down because you don't have it. And it says K equals Y over X. And you have to know what all that stands for and what it means, okay? So it's talking about constant proportionality, so we're just going to have that written down for right now, and then we'll get to it, okay? So first of all, we're going to make a ratio of Y to X. That's what the formula says, right? For all ordered pairs. What's that? What are ordered pairs? Well, what's an ordered pair?
On a coordinate grid.
Like on a coordinate grid, like that, like X, Y, right?
Yeah.
For all ordered pairs. You can see them on a coordinate grid, you can see them in a table, you can see them just written as points like that, okay? There's only one exception, and that's you do not make a ratio if X equals, what do you think? 0. Can anyone tell us why not? Okay, do me a favor. Type anything in your any number you're typing right now. Any number. And then put divide by 0. And what does it say? Undefined.
Yeah.
If you did it on your phone, it would probably say error. You can't divide by 0, you guys. So it's going to be undefined. Okay. Once you make your ratio of Y to X, you ask yourself, are all the ratios the same? If the answer is yes, then that means you have a proportional relationship. If you have different ratios, then it's not proportional. Okay? So K is equal to the ratio of Y to X in simplest form. Now, if you're given an ordered pair, like I'm giving you in a table with the X's and the Y's already there, it's easy to know what's what. Or on a graph, hopefully you know your X's and your Y's, you know what's what. When it comes to a situation, you're going to have to think, what is dependent on the other? Which one, like you said a second ago, which one is, it makes sense, which one's more likely to be the Y versus be the X? Okay, we'll talk about that again in a minute. All right, so what we're going to do, we're going to ignore 0, 0, okay, for now, because 0 over 0, we're ignoring that. And we're moving on to 3 over 1, which equals 3. Remember, we're writing it as Y over X, Y over X, okay? So this would be 6 over 2, which equals 3. 9 over 3 equals 3. 12 over 4 equals 3. So, are all of our ratios the same? Yes, so it's proportional, and since it's proportional, that means our constant of proportionality, or K, equals what? 3. Now, you can put 3, or you can put 3 over 1. Either would be okay. Do you need units? No. Constant proportionality is just a number, unlike unit rate needs the units, okay? Is everybody good so far? Okay, let's go ahead and do the next one. So, Y over X, negative 3 over negative 2 would be what?
1.5.
1.5. We can either put 1.5 or we can put 3 over 2. It just kind of depends on what they're asking you for, just as long as you recognize that they are the same. Do you think that we should only do a couple of them and then move on and be like, yeah, it's good?
No.
No, you really do need to try them all out. Tricky test makers tend to throw one in there that doesn't work. calculator, you would get that they're all 1.5 or 3 over 2. So it is proportional, therefore the K is 1.5 or 3 over 2. Okay, is everybody good so far? Do we need to do this last example, or are we good?
No.
Okay, I think we're okay. All right, now let's move on to the next section that says, well, first determine the constant proportionality in the proportional relationship, and then based on that, finish the table. So they're already telling you that it already is proportional. So once you find it one time, when I do y over x right here, 13 over 1 equals 13, then I can apply that constant proportionality to now calculate the y. So algebraically, we already know that, correct? That k equals y over x. Well, now I want to solve for just y. So algebraically, how am I going to get just y by itself?
Y.
Would it help you if I rewrote this to be up and down? How would I get rid of this x? Multiply by x, and those go away, correct? What you do to one side, you do to the other, and so now y equals kx. So do you see that? Okay, so now over here, I'm just going to take my x and multiply by k. So the k is 13, so 0 times 13 is 0. 2 times 13 is 26. 3 times 13 is 39. That's why it worked. Did everybody see how we did that? Okay. The k is 13. So on the next one, what's our k? 26 over 1, which is 26. And now what am I going to do to solve for y? Just multiply. We're going to do y equals kx. So 2 times 26 is 52. 3 times 26 is 78. And 104. We good? Okay. The last one says, use the equation to determine the table values and then identify the constant proportionality. I kind of find that's a little bit backwards. I would actually do this first. If it's y equals kx, then what's my constant proportionality in y equals 2x? 2. It's just 2. The k equals 2. It's located right there. I didn't have to do any math. It was just there, right? And so now I'm just going to use that. It's k times x. So every time I'm just going to multiply by 2 on every one of these, just like we did above. Okay, what's the k on this one? And therefore the table should be 0. Perfect. Hopefully this is not hard, yes? We're good? Okay. So far we've done it for the table, for the page. Now we're going to do it just from ordered pairs. All we want to know is if we were to plot, what they're asking you is if I was to graph these, would it be a proportional relationship, okay? So it's k equals y over x. And I have to do it with both. So that would be 8 over 2 and 60 over 4. Does everybody see where I got those numbers from? If you don't, now's the time to stop. We're good? Okay. Now let's solve it. 8 over 2 would be what? 4. 60 over 4 would be what? 15. Is that a proportional relationship? No, because those two numbers are not equal. So not proportional. No k. Okay, let me give you an example, a real life example of what this would look like. This would be like, I went to, Walmart, and I got 2 shirts for $8. So they cost me $4 each, right? And then my friend went, to Target and got 4 shirts for $60. So that meant they cost $15 each. Did we both have the same deal?
No.
No. I got my shirts a lot cheaper than my friend did. Does that make sense? Okay. Kind of. Okay, let's do the next.
Or like if you're cross-checking prices.
I'm with you. Cross-checking prices.
You look online and like which one's the better deal.
Absolutely.
That's a very everyday one.
Absolutely. Okay, this one may take you a little bit longer because you don't have to actually use your calculator. Are they equivalent?
Yes.
Yes. What are they equal to?
4.
So K equals 4. Because those ratios were the same, they're proportional, okay? So K equals 4. Is everybody good? Okay. Now, so we did it from a table, we did it from just 2 points, and now we're going to do it on a graph. It says use the graph to determine the table values and then determine the constant proportionality. Okay, so what they're saying is, here's the line, this is the line that we're talking about. We want to know where it's located. Well, the first point is at 0, 0, and then it's at 2, 3, and then 4, 6, and then it's at 6, hard for me to see that, 9. Okay, there are our points. And so now, in order to figure out constant proportionality, we have to do y over x for every point that we see besides 0, 0. Okay? So that means we're going to do 3 over 2, 6 over 4, and 9 over 6. And we have to simplify those down and see, do they all simplify in the same ratio? Do they? Yes. What do they all equal? 1.5 or 3 over 2. Okay? Now, right here to the side, I want you to write something. What do you notice so far about every time it was proportional? Okay? What do you notice? Okay, I'm looking for 2 things. You should have noticed 2 things about every one of these. Danielle, what do you think?
So like it's like the X is like it's like counting by like the same thing like it's even. So like X is counting by 2 and then Y is counting by 3.
But I want to know something that when we talk about what do we notice, we're talking about the big broad picture, meaning every single time, like here and all of this. It's something that would be true every single time. Leah, do you have something?
I don't know if it's like always 2 numbers.
Yeah, but there was 2 numbers right here, and it didn't. It wasn't. See what I mean? Oh, I want to know every time it was a guess or it was true. Winnie. Thinking. That's one thing. There is always 0, 0. Or on the graph, it passed through the origin, right? So if we were to go back to here, even when I had a table, look at this one. When I had a table right here that 0, 0 wasn't there, could we have gotten there? Right here, it was counting by 4s, right? So if I go back 4, I hit 0, yes? And here it was counting by 6. If I go back 6, do you see how I can put 0, 0 in the graph even though it didn't include that? So that would have worked, okay? If I were to actually graph these 2 points on a coordinate grid and connect them, it would have passed through the origin. You just don't know because you didn't graph it. Okay? So that was one thing. Always 0, 0. There's one more thing, and actually you wouldn't have known it until this right here. Chloe?
It always makes a steady trend.
Okay, give me simpler words.
So,
Positive straight line.
There you go, say it again. Straight line, that's what I was looking for.
straight line, linear.
It's always going to make a straight line. Okay? Those are the 2 things that you're going to notice about proportional relationships right here. If it doesn't do that, then there is not a constant of proportionality. Okay? There's one final question I want you guys to do with your table group. It says, determine from least to greatest the constant of proportionality given this graph. Write the unit rate for each graph, and then the final thing is going to be what do you notice. So don't give it what do you notice until you're for sure you know what you're doing. But what I want you to write is like graph A, it's y over x, and we're going to pick points. Obviously 0, 0 is already there, so this would be my first point that I would pick, which would be 1, 9 is that point, so that would be 9 over 1, yes. Okay, it wants us to write the unit rate, so I can't just leave it as 9 over 1, because unit rates must include units, that's the word I was looking for. So this would actually be $9 per ticket. Okay, I did the first one for you. I would like for you guys to do B and C on your own and then rank them from least to greatest.
Did you always see someone that X's is 1?
Okay, the question asked was, do you always need to pick an X that's 1? And I'm going to say no to that because, like right here, if I were to pick my X as 1 right there, that is not on a crossbar, so I don't really know what that number is. Instead, I moved over here to where I found a good number at 6. That point was 6, 3, and I'm going to continue my work from there.
Okay.
I'm going to go to the 1 here, right? Okay. Now, look at this one. Y'all, this one ended up being $1 for every 2 tickets. But, am I finished? Do you think that that's where I should leave that? This goes back to when we talked about unit rate and what makes sense. Does that make sense? To talk about the $1, or should I do 1 ticket? If I do 1 ticket, then what becomes my numerator? 50 cents, right? So it's 50 cents per ticket. Okay, this is not wrong. Okay, I guess except, well, yeah, it's asked for the unit rate, we want the 1 per ticket, right? Okay. And then for C,
But I mean, isn't that kind of the unit rate per ticket?
yeah, that's what it asked me to do.
No, the other one. This one, no, it's fine. Isn't that the unit rate per dollar?
Yes.
So they're both unit.
But we don't care. That's exactly right. We don't care what the dollar is. We care what the cost is. And the reason why that has to go on the bottom is because this is my Y, this is my X. Therefore, X has to be on the bottom, which is tickets. Tickets must go to the 1.
Oh, okay. So the if it's the unit rate, the one's on the bottom.
Yeah.
Okay.
Yeah.
I
Which
just
one
didn't-
we get
because you
X
said
at?
it was wrong because it's not unit rate.
Well, I said this one is not, because they asked specifically for unit rate, this is not a complete answer. This would have been fine if you were still comparing, just doing the comparative part, but because they asked for unit rate, that's not a complete either.
Especially since you want to compare it to other ones at one ticket.
At one
You wanna
ticket.
make sure they
That's exactly right. Okay, so for C, I got 1/3, which really means $1 for every 3 tickets, which would be about 33 cents per ticket. Okay, and so now we want to rank them from least to greatest. So which one is the least? C is the least, and A is the greatest. And now, what I want is down here on what do you notice? This should be a trend. You're looking for a trend. What do you see? Okay, you got it? All right, let's hear it.
So the less steep the line is, that the lower the cost of it.
I want it to be using terminology. I like steep, but I want this in here. Nathan, help him out.
The higher the steeper
The higher the constant proportionality, the steeper the line.
Wait, that's a higher.
Now, thinking forward.
No.
Because look, this one's the greatest one, and look, it's the steepest line, it's going straight up.
But
The lower the concept of proportionality, the lower the one, it's because it's changing at a less rate.
Oh, okay, sorry. I thought you said the less steep the line, the higher.
No, no. And moving forward, since this is still sixth grade information, anybody want to take a guess at where we're going with this? You know,
Slowly, go, make it fine.
That's not something that's talking about their families.
that's true. Say it again.
Aren't these all like triangles?
You can make right triangle, sure. But that's where we're going with that. That has nothing really, I mean,
Well,